Okay, so we're off to now into problem 2. So I'm looking at the following defect reactions of two Burgers vectors on the 1, 1, minus 1 and 1, 1, 1 plane. So I know that this is basically my normal 1 of my, basically, of this material, and this is my normal 2 of this material. These are my Burgers vectors here and here. So I'm just going to kind of go ahead and set up the equation for the resultant Burgers vectors, and we'll figure out all these different values. Let's open up Mathematica. Thinking. There we go. So I could now say that my B1 is equal to A, basically it's A over 2. Let's zoom in so that people can see. A over 2 times 1, 0, 1. And then my B2 is going to be equal to A over 2, 0, minus 1, 1, or actually 0, 1, minus 1. So those are my B2. My N1 is going to be equal to 1, 1, minus 1, 1, 1, minus 1, and my N2 is going to be equal to 1, 1, 1. Fantastic. So if I do B1 plus B2, that's going to give me my B3. So basically 1, 1, 0. So now I know, and actually we could just do now norm of B1 plus norm B2 is this greater than norm B3? So again, let's just do now slash dot A goes to 4. Yes. So the sum of our reactants is greater than that, so that reaction is spontaneous. Excellent. So found the resultant Burgers vector, spontaneous reaction. What's the slip system? So we know, looking at this value, my direction is 1, 1, 0. So essentially 1, 1, 0. So that's within that plane because you factor out that A over 2. So what material is this? So actually, we're not told essentially what this material is. But we can go. Let's go ahead and figure it out. So we've got the direction. So this could be motile in FCC currently, depending on if we're in that plane. So now becomes the question is, what is this plane? Well, I've got my B3. My T3 is going to be equal to cross, because I've got the tangent vector will lie in the intersection between those two planes. So I need to cross N1 and N2. So that will be the cross. So basically that's my T3. So now I can do basically 1, 1, minus 0. So now I can cross T3, B3, cross that. And I'm getting, and actually we could just kind of, you could even say T3, for example, is T3A is 1, minus 1, 0. And you could say that B3 is equal to, if you just want to kind of factor out 1, 1, 0. P3A is that. So we could cross this, cross T3A, P3A, and basically same thing. So our plane is the 0, actually 1, 0, 0 plane. So this is not motile in FCC. It is not motile in BCC either. And this is not, excuse me, even motile in simple cubic as well. So, not great. But that's the answer. That's it. So, a nice 25 points ready and raring for you after a laborious problem 1. So now, on to problem 3.